Hi, I'm PJ McTavish and welcome back to another DCG tutorial. So again, we're going to continue on the short questions on 2015 paper, and as I said before, this is so you can see how you got on during the exam. So the graphic below shows a trophy for the FIFA Club World Cup. A small outline elevation, which is also given, shows a trophy is based on two identical parabolic curves, AB and CD. The circle shown is tangential to the curves, and the drawing on the right shows the incomplete outline elevation of the trophy. Part A, V1 and V2 are the vertices of the parabolas, and F1 and F2 are the focal points. Draw the parabolas, show clearly how to determine the position of the points B, D, P and Q. And part B, draw the circle tangential to the curves of points P and Q respectively. Alright. So looking at this first, I thought it was similar to your directrix method, but it is nice and simple parabola, seeing as we have the vertex here and we have the rectangle that's going to fit into. Okay, so what we need to do is divide up the height and the width by an equal number of parts to find it. So what I'm going to do is draw a line out here in the angle, and we're going to pick maybe 4 equal parts, seeing as that's short enough. Okay, so that's my 4 parts, so I'm going to join the last one back to the end of the rectangle, which will be F1 here. And then I'll draw the rest of them up the same angle. Okay, so there's my 4 equal parts, and if that's the vertex up here, then these have to be drawn straight across. Okay, do the same with the height, divide up into 4 equal parts. And because these are a parabola, they get joined back to the vertex. So now, wherever they meet will give you points. So A is 1 point, and then first line, this is another point here, and here, and here, and back to the vertex. So join them in freehand lightly. Okay, so that's one half the parabola done. Now to finish it off down at the base here, I'm just going to bring my 3 points straight down, kind of like axial symmetry, and just project them over here. Now I probably need all 3 of them. What you do is put the pin of the compass in the center line, lay it at your point, and rotate them around to the base here. Okay, so point B seems to be, this is my point here, so I'm going to draw them freehand lightly. Now, if this point was up here somewhere, you would have to put in the third one just to show crossing the baseline. Okay, so that's my points here and here, and that is point B. And that's point B, then this one up here has to be point P. Okay, how would you find the parabola then from V2 to C? It's identical, they're similar, it said, so two identical parabolic curves A, B and CD. So if they're identical, project them over to the right hand side. Okay, so now that's the parabolic curves section of it, and also part A. So we're part A done, so let's draw that in strong. Okay, so that's part A done, that's your 2 parabolic curves. Now, to do part B, draw a circle tangential to the curves at point P and Q respectively. So I'm going to work off point Q here, because there's less lines and you'll be able to see it a bit better. So to get a tangent to a parabola, so we need the point on the parabola here, and we also need its focus. So if we join the focus to point Q first off, so connect the focus to your point. Then we also need a line from the point that is going to be perpendicular to the directrix. Okay, in this case the directrix is always perpendicular to the vertex and focal point line. Okay, so this is your directrix here, or we'll represent it for now. And what's going to happen now, that's going to give you an angle here, and if we bisect that angle, it will give us our tangent. But that's not what we need, okay? We need our circle to be tangential to it, so it need to be touching that line. Okay, so if it's touching that line at point Q, if we do, now this is like your solids and contact, if you do a 90-degree line to that tangent from point Q up to hit the center line, that will give us the center of our circle, and it should hit off point P then. So basically what you want to do is put in the normal now, okay? So go 90 degrees, so if we go 90 degrees to the tangent from point Q, it should give us our center point right here. Okay, let's test that out. So that's our center point. Pin the compass there. Let a point Q. Swing it around. And should meet off point P as well. Okay, so that was your center point here. Okay, so that's the circle I'm drawing in straight. So that is the question done now. So part A was your parabolic curves and part B with the circle. So I hope that looks similar to what you did in the exam. If this helped, leave a like, and we'll see you in the next one. Okay, thank you and good luck.